In this lecture, I will share some very important points about motion of a projectile. First of all, question is what is meant by a projectile? For that, let me take an example. Suppose this is horizontal direction and a gun is fitted making some angle with the horizontal direction. When bullet is fired from the gun, the bullet will move up to some height, then under the action of gravity it will come back to ground level. Such a body which is projected initially with some velocity and then it is allowed to move under the action of gravity alone, such a body is called a projectile. Today I am to share some important points about the motion of such a body which is known as a projectile. For that purpose, let me suppose this horizontal direction is nothing but x-axis and a vertical direction perpendicular to it, let me call it y-axis, because motion of projectile is in two dimensions in a plane. In this case I am taking it as xy plane, that is plane between x-axis and y-axis. Suppose this is a projectile which is initially given some velocity. Let me call this velocity as v naught vector. And this initial velocity of projectile, suppose it makes angle theta with x-axis, then I can write this initial velocity as I cap v naught x, that is x component of v naught vector, plus j cap v naught y, which is y component of initial velocity. What will be values of these components? V naught x will be equal to v naught cos theta and v naught y will be v naught cos 90 minus theta. That is a method how to find component of any vector in any direction. I want to find component of v naught vector along x-axis. I will multiply the magnitude of v naught with cos of the angle with the required direction. Similarly, in this case of y component, I will multiply v naught with cos of the angle made by velocity vector with y-axis. So this angle is 90 minus theta, so I have written 90 minus theta, and this cos 90 minus theta can be replaced by sine theta. So y component of initial velocity becomes v naught sine theta. Let me call this as equation number 1 and this as equation number 2. Next point is the body is having only acceleration due to gravity, and acceleration of body can be written as I cap into x component plus j cap into y component of acceleration. Now how to find these components of acceleration? Suppose this is a point where acceleration due to gravity is acting vertically downward, and this is our x-axis and this is our y-axis. I have to find components of this because our acceleration is nothing but g vector and magnitude of acceleration is g. As I have done earlier in case of velocity, a x component, that is component of acceleration along x-axis, can be calculated as g, magnitude of the vector, multiplied with cos of the angle. I want to find magnitude component along x-axis. It is making angle of 90 degree with the given vector, So I will write cos 90 degree, and cos 90 degree is 0, so answer comes out to be 0. Let me call it equation number 3. Similarly, component along y-axis can be written as g cos. In case of y-axis, component is here ay, and this direction is making an angle of 180 degree with our acceleration. So I will write cos of 180 degree. Cos of 180 is minus 1, so we are left with minus g. Let me call it equation number 4. Now let me suppose v vector represents velocity of projectile at any time t during its motion. So this v vector will have direction different from v naught vector, and it can also be resolved into two components. One component along x-axis, let me call it vx, and the other component along y-axis vy. So I can write instantaneous velocity as I cap vx plus j cap vy. Now we have to find these components vx and vy. For that purpose, we shall apply equation of uniformly accelerated motion, that is v equal to v naught plus a t. This equation can be applied because motion of projectile can be supposed to consist of two motions, one motion along x-axis and the second motion along y-axis. As I have proved earlier, acceleration along x-axis is 0 and acceleration along y-axis minus g. So in both the cases acceleration is constant, so the equations of uniformly accelerated motion can be applied. Using this for both x component and y component of velocity, I can write Vx equal to V naught x plus Ax t. Similarly, for y component, we can write V naught y plus Ay t. Now we have to put various values from previous equations. Putting the value of V naught x and Ax from previous results, I can write Vx is equal to V naught cos theta, and Vy can be written equal to V naught sin theta minus gt. Let me call these equation number 5 and equation number 6. Now I will apply another equation of uniformly accelerated motion, that is s equal to v naught t plus half at square for distance covered along x-axis and distance covered along y-axis, because when projectile moves it covers both distances along x-axis as well as along y-axis. So using this equation along x-axis, I can write x equal to v naught x t plus half ax t square, and for distance traveled along y-axis we can write v naught y t plus half ay t square. Now we have to put various values from previous equations and write answers for x and y. So we can write x equal to v naught cos theta into t, and this can be written as y equal to v naught sin theta into t minus half gt square. Let me call this equation number 7 and 8. Now using these 8 equations, we can derive very important results for projectile motion. So first of all, I want to derive an expression that is known as equation of motion of a projectile. How to derive this equation of motion of a projectile? For this purpose, I will have to consider equation number 7 and 8. So from equation number 7, we can find value of t is equal to x upon v naught cos theta. Put this result in equation number 8. So we can write y equal to v naught sin theta multiplied with x upon v naught cos theta minus half g x upon v naught cos theta square. Means we have just eliminated t between equation 7 and 8. Put finding value of t from 7, I have put in equation number 8. After simplifying this equation, I can write y equal to tan theta into x minus g upon 2 v naught square cos theta cos square theta multiplied with x square. So this is the required equation of motion of a projectile. Let me call it equation number 9. This equation shows that it is nothing but equation of a parabola. So this result shows that a projectile always follows a parabolic path. Next, I will share how to derive an expression for time taken by projectile to reach the highest point. As it is clear from this diagram, here h is the highest point that the projectile reaches, then it comes down. So in how much time the projectile will move from point O, point of projection, to the highest point h. Let me denote this time as t with a subscript h. So we have to find value of this time. For this purpose, I will make use of the fact that velocity of projectile along y-axis becomes 0 when time is equal to th. Means when body reaches at highest point, its motion along vertical direction becomes 0, means velocity becomes 0 along vertical direction. It is only motion along x-axis at the highest point. By making use of this fact in the expression for Vy, we can find value of Th. So using this idea in expression for Vy, I can write 0 equal to V naught sin theta minus GTH. I have replaced Vy by 0 and time t by Th. After simplifying, I can get G into Th equal to V naught sin theta, and it will give answer for required time equal to V naught sin theta divided by G. Hence the required expression for time taken to reach the highest point. Next point I want to share is what is the maximum height that the projectile can attain during its motion. The maximum height means from distance from point A to point H. So we have to find value of distance AH. Let me denote this maximum height as H with the subscript maximum. So our question is, what is the value of this H maximum? So this maximum height is nothing but value of y, that is distance covered along y axis. So I will make use of expression for distance along y axis, and that equation for reaching from point O to H, time will be th. I have earlier explained. So y equal to H maximum when time is equal to th, that is time taken to reach the highest point will give us value of y as the maximum height. By using this information in the equation for y, we can write h maximum is equal to v naught sine theta multiplied with th minus half g th square. What I have done in the expression for y, I have replaced y by h maximum and time t by th. Now we have to simplify this and get our required answer. So this will give us h maximum is equal to v naught sine theta v naught sine theta over g. I have just put the value of th derived earlier minus half g v naught sine theta over g whole square. Just putting the value of th. After simplifying, we can obtain h maximum is equal to v naught sine square theta divided by g minus 1 by 2 v naught square sine square theta divided by g. So after simplifying, I can write h maximum equal to v naught square sine square theta divided by 2g. So this is the required expression for maximum height that can be achieved by the projectile during its motion. That is the distance from point A to point H, distance of highest point from the ground level. Next point is, what is the total time of flight? Total time of flight means for how much time the projectile remains in air. Means time taken to move from point A O to point B via highest point. Let me denote this total time by capital letter T. So we have to find an expression for this capital T. It is clear that when body reaches back to ground level, y displacement becomes 0. So fact I will make use of that y equal to 0 when time taken is equal to capital T. Means in total time of flight, displacement along y-axis remains 0. Using this idea in the expression for y displacement, we can write 0 equal to v naught sine theta multiplied with capital T minus half g t square. What I have done, I have replaced y by 0 and time t by capital T in the expression for y displacement. Now we have to solve this. It will give us half gt square is equal to V naught sine theta multiplied with capital T. After simplifying, I can obtain capital T equal to 2 V naught sine theta divided by G. Hence the expression that is required for total time of flight of the projectile. The last point I want to share regarding projectile motion is horizontal range. What is the meaning of horizontal range? It is the distance from point O to point B. This horizontal distance along x-axis, maximum distance, is called horizontal range of the projectile, and it is generally denoted by capital letter R. We have to derive expression for horizontal range from O to B. It is clear range is nothing but displacement along x-axis. So we shall make use of the equation for x displacement, that is x equal to V naught cos theta into t. Just before I have written it. So what will I do? I will put x equal to r and time. What will be time for getting x equal to r? It will be total time of flight. So t will be replaced by capital T and x will be replaced by capital R. So from this equation I can write capital R is equal to V naught cos theta multiplied with capital T. Now previous derived answer for capital T can be used here. V naught cos theta, putting value of capital T, I can write 2 V naught sin theta divided by G. After simplifying, we can write R is equal to V naught square 2 sin theta cos theta divided by G. Now what is this 2 sin theta cos theta? It can be replaced by sine of 2 theta. So R comes out to be V naught square sine of 2 theta divided by G. This is the final expression for horizontal range of a projectile motion. That's all. Thank you.